Hello, students. How are you? I hope you are good, well, and fine. So, today we will discuss about constructions. Okay. So, our main outline for this lecture is to construct a line segment of a given uh, any length, and to construct its bisector, and constructing an angle and bisector of that angle, and we will see all of these with using examples. Okay, so let's jump into our topic. So before starting, what we need, so we require uh, a ruler, a compass, and a protractor for our constructions. Okay, ruler is to uh, measure or draw a given finite length. Okay, protect and a compass is to make arcs. Okay, and protector to make an specific angle or to measure specific angles that we have drawn is correct or somewhere near to correct. Okay, measure angle. Okay, now let's see our first example of line segment. So first let me give you what is line segments. So line segment meaning line segment means is a small part of a line, okay, or a finite uh, line having some finite length. Okay, so we call it as line segment. Now let's see how we draw a line segment of length 7.8 centimeter, and what we have to, our main focus is to draw perpendicular bisector. Let's first of all understand the terminologies used here. So first the bisector meaning, by meaning two. Okay, by meaning two. Here bisector meaning dividing into two equal parts. Dividing it into two equal parts. So we are given the 7.8 centimeter length of line segment, say A to B, and we have to divide it in a such way. Let's say we divide AB here point at point O, and this line must be equal to each other. So this, if we draw a line through this point, we will get our bisector of this line segment. But here there is another word which is perpendicular, but we are needing a perpendicular bisector. So here the line can also divide in this way, but we only are asking for perpendicular bisector, meaning the A and B is divided in a such way that this and this length is equal. Say this point is O, so AO length is equal to OB length, and the angle here, this angle, let's say this line, and onto this line let's name a point Z. So this angle AOZ is equals to be 90 degrees. So the perpendicular means 90-degree angle. Okay, I hope this is clear what we are trying to do here. So let's see how we are going to draw a line segment. having finite length 7.8 centimeter and draw a perpendicular bisector for that line segment. So first of all, we need to draw a 7.8 centimeter length of line segment with using ruler. So we draw it, say A, say B, A, B with length 7.8. Now we are, what we will do, we'll do uh, we put our uh, compass here and take and make our, let's say, here's our compass, here is compass, and taking length, some say half of this 7.8 length, taking more to half of this, okay, and making an arc. Let's say we make an arc here, okay. Now taking with using the same length of the compass, now we take B as our center and make another arc with the same length. So if somewhere here the arcs both intersect, and this intersection, and also below the line there is another intersection, so joining these two intersection points we will get our perpendicular bisector, okay. And we will further see this will be our 180, and this point, say O, this AO length is equals to OB length. I hope this is clear. Let's see steps. So first what we have done is draw AB of 7.8 centimeter, and then make our A as center with appropriate radius of our compass, but the radius must be more than half of AB, okay. And then drawing drawing arcs, and this arc will cut, okay, and then draw an arc. So and afterward with point B as our center with the same radius as before, we have took here, and draw arcs. So the both of the arcs cut at point P and Q, say, as shown in the figure. Let me show you our figure. So this, so if A is our center and first arc is this, as B our center, second arc is this, and joining these intersection points P and Q, we will get our perpendicular bisector, okay. I hope this is clear. Now let's prove that it is a perpendicular bisector of AB. So as I have already told you, what we have to prove, we have to prove this angle is 90 degree, and this length AO is equal to OB, okay. So we will use the congruency here, okay. And so, okay, so we have to prove this and this 2 points. So let's jump into our proof. So first what we will do. So in proof we have this A, okay, let me, this A, this B, and this P, this Q, okay. First of all, we join line like this and like this. So we have two triangles APQ, the triangle APQ, this triangle APQ and the BPQ. This BPQ triangle, we have two triangles. Okay. Now, if you see in triangle APQ, we have this this length. So, what is this length? By construction, we have took a compass and center A with this length and mark an arc here, and with the same length we took B as center and mark here another arc, and this point we get. And this, so by construction we can say if this is R, then it is also R, because the compass has changed its center but not the length. Okay, so both it is R, and this is also R. If you say, so AP is equal to BP and AQ is equals to BQ also. Okay, I hope this is clear. And if you see that we have this equals to this, that is AP equal to BP, AQ equal to QB, and we know PQ is equals to PQ, and PQ is common. PQ is common. Okay. Now, if you see by side and side property, the congruent, the corresponding, the property, the congruency property using side rule, we can say that this triangle, the both triangles are congruent to each other by SSS rule. Okay, so using, so this now we can easily say that this angle, this angle is equals to this. The angle APQ is equal to angle BPQ because of the corresponding part of congruent triangle are congruent. Okay, the corresponding part of congruent triangles are congruent. Okay, by CP, CTC, corresponding part of congruent triangles are congruent. So we now we have a this angle is APQ and this angle is BPQ. Both are equal. Now, if you try to see these two triangles, this AP, this, let me name this point as O. Now, if you see that this yellow outline triangle, this triangle, say APO, the triangle APO, and this triangle, the BPO, triangle BPO. Okay, in these two triangles, we have OP common. OP equal to OP, which is common. OP is common. And this angle, we already know this angle is also equal to each other because of this congruency part. Okay. And we also know AP, this length, is equals to BP. Okay. So if you see by side property rule, we can say this triangle APO is congruent to this triangle BPO. Okay. So now by CPCT, we can also say that AO is equal to OB. Okay. AO is equal to OB in length. So we have given proper proof that AO is equals to OB. So first point we have proved. Now what about the 90-degree angle or the perpendicularity of the line? So we know that this angle here is equals to angle here, and by corresponding part of congruent triangle, we can easily say that this angle is equal to this angle, and we know a straight line, the angle is 180. That means I can say that angle AOP plus angle BOP is equals to 180 degree, and both angles are equal. So I can easily say that 2 of angle AOP is equal to 180 degree, and angle AOP is equals to 180 degree by 2, which is 90 degree. So this angle is 90 degree, this angle is also 90 degree. So from this I can easily say that the construction we had done is the perpendicular bisector of the given line of length 7.8 centimeter. Okay. So in this way we can construct a perpendicular bisector. Okay, I hope this is clear. Let me go through proof once again. So we have this triangle. One triangle is this, another triangle is this, and we all by construction we know this is equals to this and this length is equals to this, and this is already common. So these both the blue and the red outline triangles are congruent to each other, and because they are congruent, so by if you see the corresponding part of congruent triangles must be equal. So this angle, the angle here is equals to angle here, because this both equals to in length and this is common. So this is the corresponding angle to this two sides. So these must be equal to each other. Okay. So this is by construction, this is also by construction, and PQ is common. And by SSS property we can say easily that both are congruent. So here the sign for congruency, it shows congruency of triangles. Okay, and so congruency, and then we can easily say that the APQ is equals to BPQ. And now after this we come to two other triangles. So now we will take this APO and BPO triangle. Okay, APO and BPO. We already talked about the large triangles, these triangles. We already talked about these triangles, and we come to know that these two angles are equal. Now we will talk about this little triangles here, so that we will get our result proved. Okay. Okay, I hope this is clear. Let's move. So we already saw by construction AP and BP are equal, and OP is already common side, and APO and BPO already proved that both are equal. So using angle side angle rule we can say, so this is our diagram here. O, A, B, P, this angle is equals to this angle, this length is equals to this length, this is common, and by this angle, sorry, the side here angle, side, again the side. So side angle side, by side angle side we can say triangle APO is congruent to triangle BPO. So by congruent part of congruent corresponding part of congruent triangle, we can easily say that the angle made by this two sides, what sides we are talking about, these two sides P and AO, this angle is equal to the same corresponding angle made by the corresponding sides of another triangle. So this is common, PO is already common. So the corresponding side to AO is OB. So this, now this angle is also equal to this, and we already know this total angle, this whole angle is equals to 180 degree. So the sum must be 180 degree, and half of the sum is equals to the this single angle. Okay, I hope the proof is clear, and also this AO is equals to OB in length. Okay, so our proof is done. I hope the proof is clear to everyone. Okay. Okay. Let's move to angle bisector. We have already seen if we are given an any line segment of any given length, we can easily draw a perpendicular bisector of it. Okay. So now we will talk about the angle bisector. Okay, so bisector or the bisected means the angle is divided into two equal parts. So first, what is angle? Let me give you a brief definition for it. So angle is a small gap between two rays originated from a single source, For example, here the source S and the one ray is this, say A, and another ray is this, say B. So this small gap in between we called as our angle, and this angle is measured in radians or in degrees, mainly in modern mathematics we take as in radians. Okay, so now let's move. So here, so we are given an angle, so this we are given, and we have to create a bisector of it. So we have to do something like this, that there will be, we have to draw a line or a ray originating from B, and in a such way that that line breaks this whole angle into two parts, such that this and this part must be equal. Okay, must be equal. Okay, I hope you understood the question. So let's move how we are going to do. Let me give you a rough idea, and then we will see step by step. Okay, so first we will go that let me use this given diagram. So we are given this whole information that two rays originated from B, and two rays are B A and B C. Okay, okay. Now we have now what we will do. So put our compass and take B as our center, and take half of length of BC, Okay, after taking half of length of BC, mark a small arc like this, and this arc will cut BC at here and at this point. After doing this, make another center, say this point. Now our center will be this point, and doing same using any suitable radius, but it must be half of this length. Okay, half of this two intersection point length. Okay, and then mark like an arc like this, and taking the same radius but the center at here. Now the center is here, mark like this, and this intersection and this be a source point, join them, and this ray is our a ray in a such way that it bisect our angle into two equal parts. Okay, so this we have to do this. We will see more clearly. Now let's see more clearly what I had already given you. Okay, so first with B as center, so B is here, here is our A, here is our C. I hope this is yes. Okay, so B is here, C is here, A is here. Okay, now B as center, B is center, suitable radius. We can make our compass center is here. Now taking suitable radius, though the compass needle is here, taking center here, center, and making suitable radius with like this. This is our radius, radius, making an arc which cuts ray BA. So the BA ray cuts here at point D, name it point D, and cuts the ray BC, BC. So here the point E. Okay, remember this? Okay, so now we are here. So what we are done so far? So we are come to this point as D is here, E is here. Okay, now taking D and E as center with equal radius arc which intersect each other at F point. In this step, each equal radius must be more than or half the length of DE. Always remember that. So first join this E and D. Okay, joining this E and D and putting and compass and taking E as center and taking the length half more than the half of the length DE. So this DE length. So this is our DE or ED length, and taking suppose this R here, this much length, this much radius, and making arc. Now our arc will be like this. If we take radius like this, so the arc will be like this, and now put D as our center with the same radius, making arc like this, and this will merge or will intersect at this point, and this point after intersecting we call it F, and now join B and F. So joining this B and F, we will get our ray BF, which is our required bisector of given angle ABC. Okay, I hope the diagrams are clear as okay, clear enough that you can see how we are constructing things. Okay, so let's move on to next. And now we will prove that our construction done is indeed a bisector or not. What we we will try to prove, this angle, angle ABF is equals to angle, this angle. Okay, so CBF. So we are trying to prove, okay, trying to prove this. Okay, so if BF is a bisector of angle ABC, so we have to show that angle ABF is equals to angle CBF. Okay, so how we will going to do that? So first of all, it is quite easy. So we are given, so let's write down the information we have given. So this is, say, F is here, D is here, E is here. We know this. We will try to make triangles. So we can easily use the congruency of triangles. So using this triangle, BDF and triangle BFE. So we are given two triangles. First one is yellow triangle and the second one is this purple outline triangle. So what we will do? So it is easy. By construction, we put first center as B and taken a radius, some radius R, say radius R, and mark an arc which cuts AB this and BC at D and E respectively. Okay, so this R and this length is also R. So we can easily say BD is equals to BE by construction. By constructions. Okay, by construction. We have already done such a in a such way the construction that BD is equals to BR. Okay. Now what? So we have taken two triangles. So triangle BDF and triangle say BFE. Okay. Now we first point is this BD is equals to BE. Now now what? And we can easily see that this BF is common. Okay, BF is common. BF is common. Okay, BF is already common part, common side. Okay, now what? Now, if you see that in seconds progress of our construction, we took E or D, say E as our center and took a radius half of ED, half of this length, and mark an arc like this, and with now we shifted the center on D, and with the same radius we mark our arc like this, and this intersection we got F. So by construction we have already we can easily say that this length or this DF, this DF is equal to this EF. So EF. Okay. So if you see, so by construction, by construction, so by construction, DF is equals to EF because we have taken the same length arc and uh, arc, but shifted our centers first at E and afterwards then D, but the arc length remains the same, and after making these two arcs we got our intersection point as F. So by construction we have DF is equals to EF. So from these 3 points alone, we can say that these two triangles are congruent to each other by the property of side, 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 because all the sides in this triangle is equals to the side to this triangle. Okay. I hope this is clear, as BD is equals to BE and BF is equals to BF. It is common, and DF is equals to DE. So we saw that these two triangles are congruent. Then this means the congruent sides will the corresponding sides will whatever the angle it makes in this triangle, the same angle uh, will be there in this triangle. Okay. So what I am saying here is this, that the angle in this for this triangle. So let me draw another diagram for this. So here is CAD B, we know this is E, D, and the intersection is F, and in this triangle, this green triangle, and in this triangle we see that the angle made by this sides BD and BF, that is angle DBF is equal to the angle made by this side, the BF and BE, which is EBF. From this we saw that so both of these angles are equal. Both of these angles are equal. So we saw that our main angle, the main angle was ABC, which is divided into two equal angles by the ray BF. So we have also saw that our construction was done in such a way that it creates the bisector of a given angle. I hope the proof and the construction is clear. Now let's move. It is the same explanation I have already provided you. So we have already took two triangles and put the, because of the construction, the BD is equals to BE and the DF is equals to EF and the BF is equals to BF because it is common. And then by SSS rule we can say that both of the triangles are congruent. So congruent, both of the triangles are congruent, and so by corresponding part, let me write this means the corresponding part of congruent triangle are congruent. So corresponding part of congruent triangles are congruent. Okay, CPCTC. So that is, so we can say that angle ABF is equals to angle CBF. That means the BF ray is bisects our angle ABC. Okay. Now let's jump to our examples, that how we are going to draw a 60-degree angle by just using a compass and a ruler. So uh, just draw any line segment BC of any suitable length. Let's say let me draw, so AB, or we say BC, so BC of any suitable length, of any suitable length. Okay, taking B as center with suitable radius. So any suitable radius, uh, taking taking more than half of BC. So like like uh, this like this. So I am taking this like this and making an arc. Now I am taking C as center. Now C as center with the same radius, making arc like this. Okay, making arc like this. Okay, now what? Now with the same radius, take this intersection, the radius remains the same. Okay, taking this intersection point and with the same radius, mark, now this center is this intersection point, and marking the another arc which cuts the red arc which I drew at first, and this intersection point will be my 60-degree angle. So this intersection will be my is 60-degree angle. So this angle, this whole angle is my 60-degree. I hope this is clear. Let me uh, go through it once again. Okay, so in first step, I drew a line segment with any suitable length, and at second, the taking B as center with any suitable radius, marking an arc which cuts BC at point D. Okay, so here are my BC, and this is my arc cuts at D. Okay, so this is here cuts at D. Now with the same radius, taking D as center, my arc will cut the first arc. Okay, cut the first arc. So taking as the same radius in the step 2, making another arc which cuts previous arc at E. So this intersection, okay, this intersection is my E with the same radius, and this E now joining B and E. Now let me join B and E. So this joining, this ray will say it is A. So this ray is BA, and this angle is 60-degree. I hope this is clear. So this angle is 60-degree. The whole summary is given here. So this is the BC, this first arc we had made here intersect with D, and with the same radius we mark another arc which cuts the previous arc at red point. Here we name it E, and we join B and E and produce up to A, and this ray we called BA, and this angle will be our 60-degree angle. Okay, now to construct an angle of 120-degree, it is easy. Just do the previous steps, like first draw BC. So we draw BC of any suitable length, taking B as center. Now B as center with any suitable radius. Let's say like here we mark an arc which cuts BC at D. We are just doing same process as in previous. So here we got till D. Now taking D as a center, cut this previous arc in red. So here is E point. Now taking E, now take E as center, and with same radius we are using okay, okay, mark another cut which cuts the red arc. So let's say the arc is further like this. So the original arc was like this. Okay, now taking E as a center with the same radius, this arc, now the new arc will also cut somewhere here, and this point we name it as F. Okay, and this point is F. Let me use another color. This point is F. Okay, this point is F. Now join B and F, and this joining and produce till A. So this ray BA, the ray, and the BC ray will make an make an angle with 120 degree. I hope this is clear. So in first step, BC length and taking B as any suitable radius which cuts to BC at point D, and then taking D as our center, drawing another arc of the same radius, thus radius remains the same. Keep remember this, which cuts at E, and taking E, now E will be our center with the same radius. Please do remember this, the radius remain the same. Okay, and making another cut at the first arc at point F, and joining BF will be our suitable point AB. Okay, and this is the summary. Okay, I hope it is clear. So here BC, the first arc like this at cut at point D, and with the same radius, and the center is now at D, we mark E here. Now the length or the radius remains the same, but the center is at now E. Mark the point, cut the first arc at F, and this intersection point of the F, we join B and F and produce it till A, and this angle we got, this angle is our 120, or the angle A, B and C is 120 degree. I hope this is clear. Now let's move to next. Okay, now to construct an angle of 30 degree. So just construct a 60 degree angle as in previous example. So here is BC. Okay, say BC, any suitable radius, taking any suitable radius with center B, marking a point E, marking a point say D, point is D, and with the same radius, taking with same radius but the center D, marking another point, will get our say E, will get our 60 degree angle. Now this angle is 60 degree. This is 60 degree. Okay, now we will bisect our angle. So bisect our angle meaning that is making two angles of 30 degree each. Okay, so now we will perform steps to make angle bisector. In angle bisector, let me recall you angle bisector construction. Angle bisector construction. So we are given angle, so it is given. So angle is already given. So here 60 degree. In our question it is 60 degree. Okay, so angle is already given. So now what? So taking this as our center and half of this length, making a radius half of this, more than half of this length, and making an arc. Now radius shift to this point and making another arc, and this intersection of two arcs, blue and red, we got our new point say F, and now joining this origin, the origin or the source of ray, and joining with the new intersected point F, we get our angle bisector. So this, now this will be our 30 and this will be our 30, and the whole angle, the whole is the whole or the complete angle is 60, which is 30 plus 30. So we have drawn by using angle bisector. Okay, so we have make 30-degree angle by using angle bisector construction out of 60-degree angle. Okay, I hope this is clear. Okay, so these are the steps. So it is quite easy to see. Okay, I hope this is clear to you. Now let's see, let's move to next. Now we have to construct the 90-degree angle. So first it is just construct an angle of 120-degree. So it is like, sorry, it must be like this. So how we will do for 120, let me recall you. Draw any line segment with any length, take this point as our center, mark an arc with more than half, taking radius more than half of this total line segment. For example, marking here, extending this arc like this. Okay, now my center is on this intersection point of the arc and the line segment, taking any suitable taking the suitable radius, taking the same radius like we had already took like this. We mark an angle here which will be our 60-degree. We join this is my 60-degree. Okay, now taking center here, with using the same radius, we mark another arc which intersects the first arc and join that intersection point with the origin or the source point. This whole angle is 120-degree. I hope this is clear. Now what we will do? Now we will bisect our angle. So in order to bisect, bisect our angle, let me recall you. So we are given like this. So we just take this as our center, mark an arc like this, taking more than half of the length of this, uh, make adjustment in compass and take that length more than this length, half of this length, make an arc, and now shift the center to this with the same radius, make another arc, the intersection point we will get, and join them. After joining them, we will get our angle bisector, which bisect this angle into two equal parts. We will do the same. So taking the center here, and the length is more than the half of this length, joining these 2 points. So for example, take this length and make arc here with the same length, but the center shift to now here at the yellow point, making another arc which intersect this gray arc at point say L, and this point, now L point, join this point to this origin or the source, and this angle will be our 90-degree angle. Okay, I hope this is the construction for 90-degree angle is clear. Okay, so this construction is by using, first we draw the 60-degree angle, and then the 120-degree angle, and then the bisector of this whole angle. What angle we bisected? The angle appearing, let me use this color. So angle, this angle we bisected. So bisecting this angle, we will get our new angle, which will be the 90-degree angle. So if you do use the protractor here, you will find out that this angle is precisely the 90 degree. I am using the word precisely, not exactly the 90 degree, because the construction may have errors. Okay, now let's move. So this is our final representation. So let me once again go through it. So as this will be this is our BC, the first arc is like this with any suitable length marking at D. Now D as our center with the same radius marking at E. Now E as our center marking at point G. This angle is 60. This whole angle is 120. Okay, and now taking this E as a center and making more than half of the length and making that as our new arc radius, marking another arc like here, and now shifting to center at G with the same radius as we have already just in previous step we took to mark this orange arc, and we mark here the another purple arc, and this intersection P we will get, and this will be our the angle which intersect the whole which makes the 90 degree angle, which is angle PBC. So this angle PBC, which is 90 degree. Okay, I hope the constructions are clear to you. Let's move to next. So let's see the alternate method or another method to draw a 90 degree angle. So drawing any suitable length of line segment BC. So here we have BC. Now produce CB. So we are talking about CB. So C to B is here, now producing it up to B. So we are going into this direction. Here is our O. So any point O taking any length. So we will produce to O till any length we want. Okay, now B as our center. Now taking B as our center. So here are V. So B is now our center, making an arc. Okay, now make an arc with any suitable. Okay, so like this is our arc. Let's say B as our center, this is our arc which cuts OC at D and E points. So let's say here is D point and here is E point. Okay, now as D and E as our centers, so far we are reached here. Let me draw once again. So B is C, and we produced it at O and marked an arc which cuts here at D and here at E, and as D and E as a center, let's take D as our center with equal radii, draw arc with cut each other at point P. Okay, so let's say now taking D and E as our center with equal radii, keep remember this, we will be taking equal radii. So drawing two arcs which cut our, and the one more thing to keep it in mind, that this radii we are taking here must be the half more than the half of the length DE. So this DE length must be the more, say like this, we will take this. So we mark like here. Now our center is at E with the same radius, marking like here. So this point P, now joining them, we will get our 90 degree angle. The join BP, so we join BP and produce it. So we produce it like this, and this angle will be our at 90 degree. Okay, so this PBC is our 90 degree. I hope this is clear. So BC, we produce it at O. Now taking D as center and half, taking radius of the arc more than half of this, we mark this point. Now our center is at E, marking this point, and we get this point. Okay, I hope this is clear, the construction of the 90 degree angle. Now, how we will construct a 45 degree angle? Quite easy. We will use angle bisector for it. Angle bisector steps. Okay, angle bisector. So, what angle we are going to bisect? The 90 degree angle, because bisecting the 90 degree angle will give me the two equal angles of degree 45 and 45. Okay, so just repeat the previous steps to get 90 degree angle. Suppose we get our 90 degree angle here. Now how we will going to bisect it? Say this is our 90 degree angle. So angle bisector is this. Just take this as our center using half more than the half of this length, making an arc like this. Now our center is at here with the same radius just we had already took to make green arc. Now make another arc, and this intersection we get, say it as F, and join this, the intersection, and this, the intersection of red and green point, we will get our angle bisected here, which bisect our angle here and here both at 45 degree. Okay, I hope this is also clear. Okay, now let's see. Let's move on to next. So now what? And the alternate way is to construct the 60 degree angle. Now 60 degree angle, just take any line segment, taking an arc with more than half of this line segment, say like this, with the same mark here, join them, get your 60 degree angle and bisect it. If you bisect it, now bisecting, make this as our center, marking taking radius with more than half of this length, marking arc here, taking center as here, the with the radius remains the same, marking another arc. This arc will joining them will produce our angle bisector, which is 30 and 30. Okay, which is of angle 30 and 30. Okay, for this I have recalled you how to bisect our angle. So in this we will bisect the angle ABC, which is we will be making the 30 degree and 30 degree angles. Okay, so I hope this is clear. So this is of 30 degree and this is of sorry, let me see previously. So ABC is 60 and BD is okay, yes, this is 30 and this is 30 because BD is ABC. ABC is 60 and BD is BD. Okay, now ABC is 60 and this is 30 and 30. Okay, I hope this is clear. And after doing this, now I bisect here, bisect this angle, this bisector. After bisecting it, I'll get my 45 degree. Okay, so the steps for the bisector is quite easy. So if you have to bisect at any angle, take this as our center, making more than half of this length as radius, mark an arc like this, putting center here with the same radius and joining them, we will get our angle bisector. So performing this steps, we will get our 45 degree of angle. So I hope this is clear. So to construct an angle of 105 degree, we will use a angle bisector. So first construct 180 degree angle and the 90 degree angle. Okay, to just like this, just as this is our B, and making this as our center, making an arc here with the making the same length arc here. Now putting center as here, here, and making another arc like this, we will get our 90 degree. Okay, now as when this was our 120, if you see, so this is whole is 120, this if you see is 60, and this is just the bisector. Okay, I hope if you follow the previous step, you will get the 90 degree and 120 degree. So the 90 degree will look like this and the 120 degree will look like this. Okay, now what we will do, just bisect it again. Okay, so here is our 120 and this is our 90. So bisecting these two, taking the center first as this and performing the same steps in for the angle bisector, we will get this intersection point, and joining them we will get this angle as our 105. Okay, I hope this is clear to you. So thank you. Let me finish here. I hope you enjoyed it, the constructions, and I hope the things are clear to you. So thank you for this session. Thank you.